Good day, everyone. Today we will still be discussing all about measures of dispersion. So the last time on our face-to-face discussion, we talk about on how to use the formulas for measures of dispersion, which includes range, standard deviation, and variance. But that was for raw data. Now we will be focusing on the measures of dispersion for group data. So let me just go to the file we're in nandun yung formulas for measures of dispersion. So basically, we have actually two formulas that we could work on in order to calculate for the measures of dispersion. And again, for group data, we can calculate for the variance and standard deviation. So let me introduce to you the first formula, which is for group data, we can compute the variance using the formula, which is this: s squared is equal to n times the summation of f times x squared minus the quantity of the summation of fx squared divided by n squared, where f is equal to the frequency, x is equal to the class midpoint, and n is equal to the total number of cases. And we also have another formula, which is an alternative formula for variance as well, which is s squared is equal to the summation of f, this is f, times x minus x bar squared divided by n, where f is equal to the frequency, x is equal to the class midpoint, x bar is equal to the mean, n is equal to the total number of cases. As you can see, I only have introduced to you the formula for variance. And as I have mentioned on our face-to-face discussion all about variance and standard deviation, the formulas for variance and standard deviation are just intertwined. So basically, if you have the formula for variance, you can find the value, or you can also use the formula that we have for variance for standard deviation. So what you're going to do is you are just going to take the square root of the calculated value that you have for variance to find the standard deviation. Or either you could immediately get the square root of these entire formula, just like this one. And then, of course, if you take out the square root, this will be cancelled out and you would just be left out with s, which is your standard deviation. So basically, for an example, for this case, that would be s is equal to the square root of n times the summation of f times x squared minus the quantity of the summation of fx squared divided by n squared. Okay? So anyways, let me give you an example in order for me to properly discuss on how to apply these formula in a certain data set. So what I'm going to do is I'm going to make use of the previous data set that we have, and then as you can remember, we already calculated for each the sum of each descriptive measures, and also we created a group frequency distribution table. And what I'm going to make use of is yung frequency distribution table, so that we could work on only for for the rest of the values that we need for the formula that we are going to use. So for this case, I only include the class intervals, the f and the x, because if you look at the formula, we only need this in order to calculate for the variance and the standard deviation. We only need the f, which is the frequency, the x, which is the class midpoint, and n, which is the total number of cases. And also, we need to add another column to work on the specific portion, which is the summation of f times x squared. So we could start off with x squared muna, and then after which we could calculate for f times x squared and then get the summation of it. And then we could also have the summation of fx later on, which we would start off with working on the fx first, and then we get the summation of fx. Okay, so let me add a column right here. So yan. And then let me write down that we are working on x squared first, and then we move on to your f times x squared, and then we could have the fx. Okay, now let's try to calculate first with the x squared. So we are going to focus here on the class midpoint and take the square root of each of these values. So 21 times 21 is basically 441. But let me confirm that. That is 21 times 21 is 441. Good. And then let's move on to 28. So that is 28 times 28. Okay. And excuse me, 28, which is 784. And then let's do 35 times 35. Oops. 35, which is 1225. Oops. For a while. 1225. And we could also have 42 times 42, which is 1764. Oops. Okay, 49 times 49, which is 241, 2401, I mean. And then 56 times 56, which will give you 3136. Okay, and then let's do now yung f times x squared mo. So basically, we have to multiply the f's with the x squared. So as an example, that is 3 times 441, which is 1323. Okay, and then let's do 6 times 784, which is 4704. And then let's do 7 times 1225, which would give you 8575. And then let's do 4 times 1764, which is 7056. And then let's do 5 times 2401. 5 times 2401, which is 12,005. And then let's do 5 times 3136, which is 15,680. And then let's do f times x naman. So f times x is gonna be 3 times 21, which is 63. And then 6 times 28, which is 168. And we have 7 times 35, which is 245. I think I have worked on this the last time because I calculated for the mean. 4 times 42, anyways, 4 times 42 is 168. And then 5 times 49 is 245. And then 5 times 56, which is 280. Okay, so what we need now is get the summation of this column and then also this one. So let's do that. Okay, so summation of fx squared. I keep saying columns, I think it's rows. um, get the summation of these rows. So that is summation of f times x squared. So if you do summation, we are going to add up all of these values. That's what it meant. You get sum. So 1323 plus 4,704 plus 8,575 plus 7,056 plus 12,005 plus 15,680 is 49,343. So let me write that down. And then we had this one naman, which is getting the summation of fx. So what would be the summation of fx now? So basically we just add up as well the values there. So I think we had that the last time. So we add up the values for fx, so that is 1169. So let me just copy that one. And then we can now substitute for the values that are needed in order to find for our variance. So n will be 30 times the summation of fx squared, which is 49,343, minus our summation of fx, which is 1,169 squared, divided by n squared, which is 30. So that is 30 squared. Now, we just simplify these values. 30 times 49,343 is 1,480,290 minus 1,169 squared, 1,366,000. I hope so that there are no background noises that are going to be caught up to this video, because there are a lot of background noises, by the way. I hope the headset is working. So 30 times 30 now is, anyways, 30 times 30 is 900. So yon. And then we subtract these values. 1480, 290 minus 1,366 1366 561, which will give you 113,729. Okay, divide this by 900. So you get for our variance as 126.37. So, yeah. So this is our variance. And also, if you want to calculate for the standard deviation, that is just basically taking out the square root of our variance calculated. So basically, if we do that, we are going to take the square root of s squared and the square root of this portion right here, which is 126.37, and then this could be cancelled out, and then you will get the square root of these 126.37 squared is 11.24, or approximately 11.24. So basically, this is now will be your standard deviation. Okay, so basically that's it for our first formula that we could work on in order to find these values that I mentioned. Now let us try to test the other formula, which is this formula. It's an alternative formula as well, which wherein it just requires you to get your x minus x bar and then x minus x bar squared times f. You get the summation and then divide it by n. So let's use that and compare if they would be able to have the same value. Because if they have the same value, meaning we could use both of the formulas, and whichever you are comfortable with, then nasa sayo na yun kung gagamitin mo yun. Okay? So let me add another page, and then let me just crop up this portion and then make use of these in order to present the solution for the other formula. So basically I just need this part, and then I could just add another column that we could work on in order to satisfy these values that we have. I mean, these required values that we have. So we need the x minus x bar squared. So let's do that. X minus x bar muna. And then after we get the x minus x bar, we could work on with the x minus x bar squared. So let's do x minus x bar squared here, and then f times x minus x bar squared. Okay, let's do x minus x bar. But as you can see, we needed the mean here. So if you want to use this formula, you have to make sure that you have the mean available at hand. So basically, you have to calculate for it if you don't have it. And basically, I have taught you on how to find that one the last time's discussion. For now, we already have the mean, so we just basically have to take note of that, which is x bar is equal to 38.97. So what we are going to do is subtract these mean to each of the midpoints here. So that would be 38.97 minus 21 first. That is 70. Supposedly it would be the other way around pala. That is 21 minus 38.97, which would give you negative 17.97. But anyways, even though maging negative siya dito, it would be squared here. So basically, it would give you still a positive value. But of course, if you want to be correct, you have to put in the negative sign here, because that's basically its original value. If you want to notate each of the values here on these x minus x bar in a portion. So moving on, 28 minus 38.97 is negative 10.97. And then let's move on to the next one, which is 35 minus 38.97, which would give you negative 3.97. And then let's do 42 minus 38.97, which is 3.03. And then 49 minus 38.97, which is 10.03. And then 56 minus 38.97, which is 17.03. And then we take out the squares of this, because that is what is needed here. So if you take the square of 17.97 or negative 17.97, that would be 322.9209. So let me write that down. And then negative 10.97 squared is, negative 10.97 squared is 120 0.3409, and then negative 3.97 squared is 15.7609. And then let's do 3.03 squared is 9.1809. And then let's do 10.03 squared, which is 100.6009. And then also have 17.03 squared, which is 290.0209. 0.0209. Okay, now let's do the last one, which is basically f times x minus x bar squared, which is just basically multiplying our values here with f. So if we start off with the first one, that is 322.9209 times 3. 0.9209 times 3. Oh, 322.9209 times 3, which is 968.7627 to 7627. Now let's move on to the next one. 120.3409. 120.3409. No, 120.3409 times 6, which is 722.0454. And then let's do 7 times 15.7069, should give you 110.3263. And then 4 times 9.1809, which would give you 36.7236. And then 100.609 6,009 times 5 to give you 503.00545. And then 5 times 290.0209, which will give you 1450.1045. 50.1045. Now we take the summation of this. So basically that's the summation of f times x minus x bar squared. So we will be just adding up these values. So that is 968.7627 plus 722.0454 054 plus 110.3263 is 110.3263 plus 36.7236 is 36.7236 plus 500 oh no plus 504 point 503, I mean 503.0045 plus 1450.1045. Okay, so that's 3790.967. So that's 3790.967. Okay, now we could just substitute that one to our formula now. So that is going to be s squared is equal to, which is this one, summation of f times x minus x bar squared, which is 3790.9 point 967, and then we could divide it with n, which is given here, which is 30. Now if we do that, that would be divided by 30, it will give you 126.37 as well. So as you can see, whichever formula you would use, you would come up with the same value. So as I was reminding you, you could use whichever you are comfortable with. So this is going to be our standard deviation now, which is the same thing lang doon sa value natin a while ago. So S is still 11.24. So I think that's all that I need to discuss for group data. For in terms of the measures of dispersion, I'll be just giving you an activity, since I wouldn't be able to conduct a face-to-face discussion in Monday because I have an event to attend to. So if you have any questions, just tell me, and you could just send it through our GC, and I'll be just I'll just entertain it when I have free time. Okay. Anyways, that's all. Goodbye.